Okay, we're going to be looking at symmetry of graphs, and we're going to be looking at symmetry with respect to the x-axis, the y-axis, and the origin. You know what it means to have symmetry with respect to the x-axis and the y-axis. Symmetry around the origin means that the graph can be rotated 180 degrees and the results coincide with the original graph. Look at this first graph where we're illustrating symmetry around the x-axis. Notice that if you fold the picture around that dotted line there, then the bottom part of that graph is going to match up with the top part of the graph. You have x coordinates for this point up here, and you have an x coordinate for this point down here. And the y coordinates are opposites. Y and negative y are both on that graph. So that comes back up here to my definition. If xy is on the graph, x negative y is on the graph. Now in my next picture, I have symmetry about the y-axis. I have the point negative xy on the graph and the point xy on the graph. So the x's are opposites and the y values are both the same. When I'm looking for symmetry here, I notice that the x values are opposites and the y values are opposites as well. So we're going to use those definitions to help us test for symmetry. So to find symmetry about the x-axis, you're going to replace y with negative y. Symmetry about the y-axis, you're going to replace x with negative x. And for symmetry about the origin, you're going to replace the x with negative x and the y with negative y. And the equation that you end up with is equal to the one you started with, then you have symmetry. Okay, I want to figure out if there's symmetry with respect to the x-axis, the y-axis, and the origin. So I'm going to organize my work like this. I'm going to figure out symmetry about the x-axis here, y-axis, and the origin. Okay, to find out if there's symmetry about the x-axis, I'm going to replace y with negative y up here in my original problem. Okay, now I need to try to simplify this. X squared is just x squared. If I take negative y and raise it to the fourth power, I get y to the fourth power, and that's going to equal 5. So this is exactly what I started with up here. So there is symmetry about the x-axis. And now let's look for symmetry about the y-axis. I'm going to replace x with negative x. I want to see if this function is equal to what I started with. Well, negative x squared is the same thing as x squared. So I can see that there is going to be symmetry here as well. So this was a yes, and this was a yes. And now I'm going to see if there's symmetry around the origin. So replace x with negative x, replace y with negative y, and see if I can simplify this and make it look like the starting problem. And it does. X squared plus y to the fourth equals 5. That's exactly what I started with, so there's symmetry there as well. Okay, problem number 2. Again, I'm going to organize my work the same way. I'm going to replace y with negative y. And this equation is not the same that I started with, so there's no symmetry there. To figure out if there's symmetry about the y-axis, I'm going to replace x with negative x. And that's not what I started with, so there's no symmetry there. To figure out if there's symmetry around the origin, I'm going to replace y with negative y. And I'm going to replace x with negative x. Now there's a couple of different things that I can do from here to figure out how to deal with those negatives, but I think you can see that the negatives on both sides are just going to go away. So y equals 3 over x, and that is exactly what I started with. So there is symmetry around the origin. Okay, for my last example, to figure if there's symmetry around the x-axis, I'm going to replace y with negative y. I'm going to see if that equals the absolute value of x minus 6, and it doesn't. To figure out if there's symmetry around the y-axis, I'll replace x with negative x, and the absolute value of negative x is the same thing as x. So that's exactly what I started with, so there's symmetry there. And to figure out if there's symmetry around the origin, I replace y with negative y, x with negative x. So this is negative y equals the absolute value of x minus 6. And that's not what I started with, so there's no symmetry there. Okay, just real quick here, you need to be real sure that you remember that when you are figuring out symmetry for the x-axis, you replace the y's. And when you're trying to figure out symmetry for the y-axis, you replace the x's. Right? They're just opposites. To figure out symmetry for the x-axis, you replace the y's. For the y-axis, you replace the x's.